Hi Riti, how are you?
Hi, I'm good. How are you?
Also good, thank you. Hope you had good time during your
Yeah,
vacation.
all good. Yep.
Good,
Thank you.
fantastic. Yeah. So let's start. I think last time we covered multivariate, like small chapter, like
Yes.
quite related to what we already studied in uh, prior chapters. But this one is little lengthy as well as important. So, important topics, if I were to just list down, are like skewness, and these are like good to know, like just like from fundamental understanding point of view. These are good to know. Like these would be required in your paper for valuation and risk model. Just a fundamental understanding, not really the questions directly are asked on this. So from this chapter, skewness, kurtosis, and like we'll talk about few types of correlations. So that these are the like key topics, but yeah, overall little lengthier. So let's start. Uh, Firstly, let's understand in stats why we have population and sample. So just imagine if any FMCG company were to launch a product, they cannot conduct research at a country level. Like it's not really practically possible to study your target audience individually. So what is done, like you define your demographics, and
Right.
based on that samples are chosen, and those samples are studied, and like with certain like confidence you infer about population. So that's the a very high level idea why you have population and sample kind of terminologies in stats. So let's see like what we have. So there are few notations that you need to know. When we talk about X bar, it is kind of your sample mean. So how do you derive your sample mean? You just sum all your data points in your sample and divide it by the number of data points. So let's lead. I mean, I have already explained, but let's see what is there in the slide. In order to compute population mean, all observed value in a populations are summed x and divided by, like the formula will remain same. If you are able to count your population, great. If not, then you have, as I said, that sample approach would be followed. The sample mean is sum of all values in a sample population, summation x divided by the number of observations. So it's technically same, it's just a notation. When you say x bar, you are referring to sample mean. And when you talk about population mean, it's a letter mu that you are talking about.
Okay.
And next one is variance, very important one in finance. So see, I'll just explain. I think previously also I have explained, but just in case, just for the brush up. So just think of this as a wooden board, and like I'm just explaining what is the mean in context of some example from physics. So just think of this as a wooden board, and like the distribution of weight across this board is not really consistent. Like you can just imagine that on this side of wooden board it is slightly intense or heavier. So the problem statement is, I mean, I need to uh, put needle somewhere so that this board is balanced. So wherever you put needle, like because it's heavier on this side, your mean or the center would be slightly here. So like you will keep like balance over here so that your wooden board is in a static position. Are you able to follow? Like this is something I'm relating mean with a center. Mean is also central tendency. This is in context of physics, and we will
Yeah.
talk about like finance. So this is like your mean central
Mm,
point, what we talked about X bar and mu in a previous slide. Now, if I were to talk about variance, so I need to look at like just think of masses. Like there would be if I were to uh, say that the weight at this or mass or intensity at this point is x1, x2. So like how the dispersion of the data is, that's where your variance or standard deviation will come into the picture. And how it is calculated, you first calculate your center, like your center of data, and then you calculate distance of each data point from the center. Like this is like deviation from mean for x1. Likewise, you can have deviation for x2 from mean, and followed by you can just talk about deviation of ith data point from the mean. And one more important point, can you intuitively think why we should be squaring deviations just in case if you're aware? Otherwise, I
Yeah,
can.
I think you told me like from one, like if we are going from the mean to the data point, and then we have to get back from the data point to the mean. So maybe that's why.
S- I'll just give you with the example. Say, for example, distance of x1 from mean is so x1 is when I say minus 5, like indirectly I'm saying that x1 is on the left side of the mean. And like suppose there is some another data point on the right hand side of the mean. So I'll compute x2 minus mu, which is 5. If I don't square, if I just directly add these up,
Mm.
suppose I just have two data
Okay,
points.
understood. So there will be no, yeah, there will be a zero.
So this will like it will give you sense that there is no dispersion in your data point, whereas actually there is a like material dispersion in your data set. Like one is on the rightmost side and one is on the leftmost side, like leftmost and rightmost. So that's why what we do, we square deviations and then we divide it by n. And likewise, later on, the square root is also taken because the squaring is only done just to ensure that these deviations do not offset each other.
Right.
Is it making
Understood.
sense?
Yeah.
Cool. So
So
this is,
sigma square is the variance, right?
yes, that's correct. So variance is sigma square and standard, like when you take a square root, it is standard deviation, that is sigma.
Yes. So standard deviation is basically the square root of variance.
Yes, that's correct. Okay, all good with understanding mean and variance.
Yeah.
Okay. One more important point I would emphasize when you talk about population standard deviation or variance, we denote it by sigma. If I talk about sample mean or sample variance, I denote it by S square and S. And
Okay.
the only change that happens in formula for variance of sample is denominator is n minus 1 in this case. Any idea why that could be the case? Like just intuitively.
Uh,
Just think for 30 seconds, otherwise I'll answer.
mm, so we are just my subtracting one sample from the entire sample size. So why should be that?
Uh yeah. So n minus 1 because see there would be one data point
Mm.
for which like deviation would be already known. Like listen to me carefully. Like this one data point would be mu. So
Okay.
deviation of one data point is already fixed. Like so
Mm.
this mu also would be one of the data point, right? Out of the data set. So
Mm.
this deviation is not something which is not known to us. This is already known to us. That's why we in this case we divide it by n minus 1. Of course you don't have to calculate, but just in case like you're going for an interviews or like these questions usually like sometimes are asked.
Okay.
So yeah.
Understood.
So yeah, I think this was something I was talking about. So this is like sample variance and sample standard deviation. So I'll move ahead. I think We spoke about it.
There was a like a example in the previous slide. Can you go to that?
Sure.
Yeah, okay. So example, return on four stocks is this. The population mean other mu is okay, right. So they have asked us to calculate the variance.
Yes, but no need to do go as per this. Like in your Calci, you have directly can do it. If you want, I can
Yeah.
just tell you the steps, and you can get the 98.5 directly. So this particular calculation you will not be expected to do in the exam. Like it's a good to know from your understanding point of view, but from exam point of view, your financial calculator directly
Calculates it.
yeah.
Hmm.
So if you want, I
Okay.
can just tell you these steps and you can give a try. But usually, like exam is not really that trivial. So like hardly this kind of question would be asked. But yeah, if you're keen, I can just tell you in a minute.
Yeah. No, you can tell me later also. That's okay.
Sure. Yeah. So that's about sample variance and standard deviation.
Hmm.
And this is something interesting. So be attentive. Understanding mean and variance of population and sample. So now we'll just try to understand how sample mean and population mean, likewise sample variance and population variance behaves with certain we'll use this example. So just think there are four scientists who are quite old and their ages are like 78, 76, 72, and 74. So if I consider this entire set to be population, like there is nothing, this is kind of a superset.
Hmm.
And if you just calculate average, so average is 75. And
Hmm.
like if you can just substitute in your calci and calculate sigma, it's 2.236 that you will get. And the
But here, just a moment.
sure,
So here, what is the mu? We
mu
don't.
is 75.
Okay, 75. Yeah, okay, we got the mean. We
Yeah,
got the mean. Okay,
yeah.
got it, got it.
And variance is 2.236. If you want, you can just give a try, or I can. Shall we try with this data set on Kelsey because this is quite in above one. We had percentage, so might would have been bit difficult given you'd be doing it for first time. So would you like to give a try for this one, or like that's fine because usually those are not asked in the exam, to be honest.
Yeah. No, I think it's okay. We can, like, I can give a try when I'm doing
Perfect,
actual questions, right? So,
perfect, yeah. So and if I were to just calculate plot a probability distribution, like what is the probability that if I choose random one, I'll get 70. So you can just think of this as a sample. What is the chance that if I pick any of the random uh, person from this set, it would be 78. So that's why it is saying it's 25% for all the people because there are
mm,
four elements. The probability of each outcome would be 25%. So this is about the population mean, population standard deviation, and the distribution of the probabilities.
mm,
Are we good so far? This is just a proper absolute, like it's the age of Andrew, Jack, Michelle, and Tom. But let's focus on this one. Let's see how it changes when we talk about the sample. Is it clear so far?
yeah, yeah.
Okay. Now, just think from same population,
Mm,
if we are drawing sample of two, like out of four, I'm
mm,
just doing a sampling. I'm choosing two samples each time. See
mm,
overall, like how many possibilities are there. Like this is just you can just think of this as a matrix. When I choose two
mm,
samples, two sample elements or two sets element from
mm,
the population, it could be 78, 78. it could be 76 and 78. Likewise, you can like the diagonal elements are equal one 76, 76, 74, 74,
Yeah.
72, 72. Likewise, we can just combine 76, 78,
Yeah.
74, 78, 72. So like
Yeah.
78 is attached with all these four. Likewise,
Yeah.
in this case, 76 is attached with all these elements on the top. And so this is how the sampling can be done. You if I were to choose two sets, so these are all possibilities. Now, if I calculate the mean of this sample, so for first sample, my mean would be 78. For second sample, my mean would be 77. Like average of like midpoint of these two would be
Yeah.
77. Likewise, you can do it for all 16 blocks in
Hmm.
this matrix. So this would be now this is set. What you see over here, this is set of sample means. So
Hmm.
these were your samples of size 2. Now
Hmm.
you have got one set which has sample means.
Hmm.
Okay.
Right.
You have got 16 sample means.
Hmm.
Now, if I plot probability distribution of this sample mean,
Hmm.
like firstly, can you tell me which of the uh, element is appearing highest number of times just looking at the this matrix inside this red highlighted area?
I feel it's 75.
75 you see here, like it's
Yeah.
appearing 4 times. So
Yeah.
out of 16 sets,
Hmm.
like 4 times 75 is appearing. So
Yeah.
75 probability is 25%. So this is a distribution of sam- sample means. So distribution of sample means 75% as highest probability, which is 25%.
Yeah.
Likewise, if you notice these numbers
Hmm.
72 and 78, like it appears like a housey game that we played. And I'm
Yeah.
not sure if you played when I'm circling, it
Yeah.
appears in that way. So,
Yeah. Yeah.
so yeah, 72 and 78 are
Yeah.
appearing least number of times. So 1 over
That's right.
16. 1
Yeah.
over 16, you can just calculate it. It would be like around how much? 16, 6 are 96, so around 6%. So
Yeah.
like approximately. So likewise, you can calculate the probability distribution of the sample means. So now let's try relating what we got for population and sample.
Hmm.
So if you see the mean of sample is also 75. If you just sum it up and divide it by 16, you will get 75. You can give a try. Okay.
Okay.
So it's 75. Now very important thing is
Hmm.
standard deviation, which was again earlier 2.236, it went down to 1.58. So
Hmm.
from this, we can make two important points. We can like note it or down or just observe. So the mean remains same for both cases, and variance is lower
Hmm.
when you draw samples. So
Hmm.
the inference would be variance of sample mean
Hmm.
distribution. So whatever we were looking at was distribution of sample means decreases with increases in sample size. Earlier, like when we had this population, we just had like one sample. Like, I mean, one sample, it would be just one, this data set only. But when we increase the sample size, we drawn two samples out of this. You can again give a try for three samples, but that would be a bit complex. Uh, that would have like how many sets? Like in this case, you had two. So you had 4 to the power 2 sets,
Hmm.
like 16.
Yeah.
When you had 4 elements and you increase the size to 2, you had 4 to the power 2. But like when you have 3, perhaps it would be the bigger one, like
Mm-hmm.
the matrix would be slightly
64.
slightly. Yeah, perhaps I would think yes, it would be 64, or I think it was 2 to the power 4. We had sample size of 2 and we had 4 elements. Like, let's not go to generalization. Like, I can come back to you on this after thinking something, because currently that's not important, but it would be little bigger. Like,
Yes.
we can bit difficult, like how we tackle this manually. For that
Mm-hmm.
one, it would be like we would need some good
Yeah.
sophisticated software to tackle that data.
Yeah.
So, but the inference is that increases in the sample size will decrease your
Decrease the
variance.
mean variance. Sorry. Yeah.
Yeah, variance of sample mean distribution. Like, this distribution was of the sample means. Like, these are
Sample.
means, right? This
Yeah.
like this samples. This is a 78 is mean of this sample.
Yeah.
77 is mean of this sample. Is it
Yes.
making
Yes.
sense?
Yes.
Okay. And just make a note of this formula.
Mm-hmm.
Uh, the this term there is term defined which is called as a standard error, which is divided, which is, you can make a note of it. Just standard error, which is calculated by dividing your standard deviation by square root of sample size. So as your sample size goes up, your standard error will go down. You will have the less variability in your data. Okay.
Square of standard error is square of sorry variance over the number of
Square root of n.
what was n here?
N is your sample size. Like how we, uh, like in this case, our sample
2
size
was
was
the sample. So yeah.
okay.
Okay.
So let's move ahead. These are just literature like point estimates and point estimators. So sample parameters can be used to draw conclusion about true population parameters. So when I say population parameters, I'm referring to mean and variance. If they are not known, you can draw conclusion using the sample parameters. Point estimates are single values used to estimate population parameters, and formula used to compute point estimate is known as a estimator. It's just sample mean and variance that are referred, which you use to infer about the population parameters.
Mhm.
The mean estimator is a formula that transform into an estimate of a true population mean using observed data from the sample of the population, just whatever we just spoke now.
Okay.
And these are few properties that your estimator should have, like your when you have like there should be a linearity. If I'm if I'm if I were to extrapolate, say for example, you had some sample estimators, like you have sample variance and mean. If you increase your n, are you able to extrapolate those unique using the linear regression? That's the property. Like your sample, it should have the linearity. Like whatever estimators that you are getting from your sample, if these are linear, then you say, like, there is one term called as a blue, which is best linear unbiased estimator. Like if your estimators are linear as well as unbiased, when I say unbiased, that means that they are able to give you the best approximation for your population, or they are not, like your those are not biased. Like for any samples, they are replicating what is happening in the population. So those are, that's properties called as unbiased. And
Mhm.
consistency is just a formula. Large samples, better estimator. It should not happen that when you're increasing your sample size, your estimators are in fact going in other direction. So ideally, these should be consistent. With larger samples, you should have less standard error or variability in your data. And if this estimator possesses this property, then you say your estimator is best linear unbiased.
Okay.
I think yeah, here it is. So if this if your estimator exhibits this property, you say your estimator is blue.
Okay.
And central limit theorem, usually questions are not asked, but very very interesting area wherein like interview questions can be asked. For any population with mean mu and variance sigma square, as the sample size of random sample gets large, the distribution of sample mean approaches to the normal distribution with mean mu and variance sigma by square by n. So whatever I just demonstrated here, like if you see, as your sample size goes up, like from 1 we came to 2. So
Hmm.
what happened? Your sample distribution of the mean, sorry, sample distribution of, sorry, distribution of sample means
Hmm.
10 to the normal distribution with mean mu. Like if you see the mu was same 75, 75. And this is like, and the variance as sigma square by root n. So like if you calculate this 1.5, I mean, you can calculate using this also. You can use this variance divided by root n. You will get approximately this number. So that's what it is saying, that as your sample size gets large, the
Hmm.
sample means approaches normal distribution as we saw, with the mean mu and variance as sigma square by n, where your sigma square is uh, the population variance. Is it clear? Like people can ask, so you can just say that as your n tends to infinity, your
Hmm.
distribution like x tends to the normal distribution with mu and variance sigma square by n. That's the interpretation of central limit theorem. This allows us to make inference about construct confidence level interval of our population means based on the sample means. Like how you now you have sample means data, like how we saw in the earlier slides. What you can do, you can create confidence interval. I'll explain this you. What is this? Like basically, it means that, say for example, I'm asking you like, or uh, uh, you are a researcher. I'm asking you like being a end user. I'm saying give me a range for my population mean with 95% confidence. So from this sample means you will be in a position to tell me two numbers. Like when we say interval, this is kind of interval with some confidence level. You will be in a position to tell me your population mean would be based between these two with
Hmm.
95% confidence, 99% confidence. That's something which is case to case basis. Is that clear?
Yeah. Okay.
Okay, cool. So skewness, like in this case, like if you see, if I keep a mirror here, like this is a data distribution. If I keep mirror here, like these both are symmetric. So
Yeah.
skewness measures the degree to which distribution lacks a symmetry. So
Hmm.
like it's a measure of symmetry. When your distribution is normal, you say that your skewness is zero because
Yeah.
it's kind of a symmetric. There is no skewness, yeah, inclination towards any side. Okay.
Right. Yeah. Yes.
And when we notice that like you have data it's skewed towards right, you say
Hmm.
you have positive skewness or right skewness. Positive skew has a outliers and right tail. So this is a right tail.
Yeah.
And very important point, pull on right tail to get positive skewness. So your data slightly gets pulled towards the right. And very important point to note, wherever your data gets stretched, as I said that if you remember my wooden board example, I said that on the top side there is a heavier weight, so my center would be near to that. So with the same analogy, I can say that wherever you have stretched tails, your mean gets pulled towards that side.
Right.
See, median would be always between mean and mode. Okay, for
Yeah.
this one, when we did not have any skewness, your mean, median, and mode were equal.
Yeah.
But when you have got right skewness, your
Hmm.
mean gets pulled towards the right, median is always in between, and the mode would be on the
Yeah.
rightmost side. So I would ask you to remember in a way that wherever your tail will lie, tail would be heavier, your mean would get pulled toward that side. So you can
Okay.
always say that in this right skewness case, mean would be highest, followed by median, followed by. Is it clear? So you can see here, mean is highest, followed by median.
Question, yeah,
Please.
just one question I had. So basically, like now we are doing the quantitative, right? So like at the end of the quantitative module, we'll do some questions also, right? Because right now we are just going into theory. Uh,
Yeah. Of course, we'll do, and we have, in fact, the end of this chapter also that will test your this understanding, whatever I was just explaining you.
okay, fine, fine.
And this one, like as the tail gets towards the left, your mean got slided towards the left. So this is called as a negative skew or left skew, wherein your tail is on the left side or negative side. Your mean also gets shifted towards that side,
Hmm,
followed by, so in this case, mean would be lowest, followed by median. Median would be always in between. So very easy way to think, wherever you have skewness, your mean would be on that side. Okay.
right.
So that's about skewness. And now we'll talk about kurtosis. See, kurtosis, I'll just help you with few terms now, which you may not get in book, but sometimes in questions those are asked. So uh, look at this diagram. One with the highest kurtosis. So it's basically, see, for understanding, think kurtosis is a measure of peakness.
Hmm,
In the skewness, we were talking about symmetry. But
yeah.
when we are talking about kurtosis, see,
Hmm,
there are four movements of the data. What I
hmm,
mean, there are more, but those are bit theoretical. In practical world, you study four center of datas. Like we studied about mean, we studied which is first central movement, variance is second central movement, skewness is third central movement, kurtosis is a fourth central movement. In FRM curriculum, we have to study till the fourth central movement.
yes,
Okay,
correct.
and kurtosis, mostly from understanding point of view, you can just think that it is a measure of peakness. But when you will deal with more questions, be it like the institute or like anything, sometimes the kurtosis is also related to the thickness of the tails, like fatter tails, or like we can just do one or two questions that will you, or you can just see that leptocortic or thinner tails. What happened that in leptokurtic, your data from tails gets slightly shifted in the slightly nearby mean. So your mean is here. Okay, so
Hmm,
what happens? You can just think, when you, if I stretch this data, like earlier, say this green one that you see in between.
hmm,
If I stretch this slightly this side, I'm what essentially I'm doing, I'm pulling the data from tails near to
hmm,
the center. That's why when you have leptokurtic, your tails become thinner.
hmm,
Okay. So that's the leptokurtic, which has And if you are making notes, just make a note. We
Mm,
talk about two terms here. Like one is kurtosis, one is excess kurtosis.
mm,
Okay, when I talk about excess kurtosis,
mm.
it is over and above kurtosis of the normal distribution. So if you see here, like normal distribution has a kurtosis of 3.
Okay.
Okay, so can I ask you a little tricky question here?
Yeah.
If just give a try, it's fine. Not really tricky. In fact, like what would be the excess kurtosis of the normal distribution?
Excess kurtosis.
See, I'll
Mm,
just help you with a formula.
mm,
Excess kurtosis is equal to
mm.
kurtosis of your distribution minus 3. Now give a try. Look at this statement.
Mm.
I'm saying your distribution is normal. What should be my excess kurtosis?
Uh, 0.
Perfect. Yeah, just I was just trying to stimulate and just bring your attention. I know the topics are a bit complex. That's why I just very good. So excess kurtosis is kurtosis minus 3. What I just wrote
Mm.
here.
Yeah.
So for normal distribution, it is 3, and
Mm,
one distribution which have excess kurtosis greater than 3 are called as leptokurtic, and those will have thinner tails. And as you spotted, or mesokurtic, that will have a 0 excess kurtosis, and one with a platykurtic will have the negative excess kurtosis.
mm. Okay.
Okay, and
Mm,
this ones will have a thinner tails, and
mm.
this platykurtic will have a fatter tails. Just make a notes of it, and like it will help you. Like there are questions on skewness and kurtosis, and these are low hanging fruit, to be honest. If you just know whatever I just explained you in last 10 minutes, you can just easily hook 1 or 2 marks.
Okay. Got it.
Okay,
So
shall we
basically,
move ahead?
I have to understand that the excess kurtosis um for leptokurtic are greater than 3,
Perfect.
right?
Yep.
And the excess kurtosis for platykurtic kurtosis is less than 3, right?
It would be negative, like because
Negative.
see what will happen if your distribution is tachycardic, it will have somewhere kurtosis say less 2, or because for normal it is 3, because your it is leptocardic it is 2, so it would be less than 0. So that's why it says negative. It will
Hmm.
have positive because it the for
Is it
some
like negative or positive or greater than 3 or less than 3?
see when you just talk about kurtosis, it would be greater than 3 or less than 3. When you
That,
talk about excess kurtosis, it would be positive, negative, or 0.
okay, got it.
Make sense?
Yeah, makes sense.
Okay. Any other doubts, or you want to make a note of it?
Yeah, I've made the note.
Fantastic. And another formula, like how you studied about variance, we have to study about covariance. When we say covariance, I'm talking about two random variables here. Like you can see stock 1, stock 2. How do you calculate the covariance? It's the same process that you did for calculating variance. Can you tell me what we did for calculating variance?
For variance, we did the for variance we subtracted the
Mm-hmm.
uh, yeah subtracted I think forgot what was x.
No problem. Yeah. So
The sample mean,
yeah, no problem. See, in general, forget about the formula for a moment. Let's forget about the formulas. What is variance? Just understanding. Tell me understanding. Formulas will come along.
Like deviation from the mean.
Perfect. Deviation of from the mean. So it's just X is a data point you're trying to calculate. See, uh, I would suggest don't go in a school mode like teacher is asking and you have to answer.
No,
Like
no, no,
just
no.
prepare,
That's okay.
be open. Uh, yeah. So data point less your mean.
Yeah,
Data point less your mean for both data set. Multiplication of those,
yeah,
summation of that, divide by your n minus one.
yeah. Right. But
So
right now, why we are doing n minus one?
uh, you tell me
Mm,
because if I know this R1 bar is going to be one of my data point, then
mm,
you already know deviation of that data point would be zero,
mm,
right? So it's kind of see why we divided by n for whatever we don't know. But in general, when I talk about sample,
mm.
for sample, I know that deviation of one data point from mean is going to be zero because one of data point is mean itself.
Yeah, okay, okay, okay.
Okay, so that is the reason instead of n, we divided by n minus 1 in case of sample.
Yeah, exactly. So
Okay,
basically, it's not the uh, but I didn't get it. Like, okay, just it's just the formula. Maybe in variance we are only putting n, and but in covariance variance the formula says so. You know that it
in
should be n minus one.
in sample variance also it was n minus 1. Let me go back to slides. So if I circle it for
Variance.
sample, it was already n minus 1. What I think you are referring to is population.
Okay, so that's the population variance,
In
right?
case of just remember for population, it is always going to be n in the denominator. Whenever you're talking about sample, it is going to be n minus 1.
Right. Yeah. Okay.
Okay.
Yeah.
So that's about covariance. And you can skip this calculation honestly. Like if you're interested, you can just take a snip of it and do a calculation. Otherwise, not really required from the exam point of view.
I'll do. Acha, okay. So exam point of view, it's not required. Then I'll not do.
No, honestly, not required. You can just skip these. Okay.
Okay.
So sample covariance. Uh, there is another formula also for covariance when you are not given values like this. So these were what these were values actually. 5%, 7%, these were stock returns,
Mm,
negative 2%. But when you're given what is the likelihood of getting this 5%? Say for example, now what is happening for stock one? These all three have equal probability. Like 5% can if I were to calculate mean, can you tell me how will I calculate mean for the stock one returns?
uh,
This is your data. I want to calculate it mean. This is think of this as a population for now.
mm. Okay, so it should be like sum of all divided by
N,
numbers.
right? That is 3. So what will happen like when I divide it by 3? So I'm eventually saying that there is when I divide it by 3, it's kind of I'm multiplying it with by 1 by 3. Like this is my x1, this is my x2, this is my x3. So when I
Yeah.
divide it by 1 by 3, essentially what I'm saying that there is a 33% probability of this may come up, this may come up. So in when you are given absolute data, you are indirectly saying that the probability of each thing happening is 1 by 3, like 1 by n. In general, it can be anything, but
Mm,
there could be another data set you might be given, like which might be in this case, like you
mm,
are suppose given stock one chances of getting 5% return. So this is, you can say, X. This is, you can say, probability of X. Chances of getting 5% returns is, say, 20%. Okay. And chances of getting negative 2% is 50%, just as a random numbers I'm putting. And chances of getting 10% is 30%. Like essentially now it is 100%. So in
Yeah.
this case, what is happening that earlier the probability of occurrence of each of these three was equal, that was 33%. Now, if you're given data set like this, that your probability of 5% is 20%, probability of getting negative 2% is 50%, probability of getting 10% is 30%, then you have to be slightly, I mean, the process is slightly different. In that case, earlier how you were calculating mean was, it was like you were calculating sum of data points, dividing it by the number of data points. In this case, in this case of type of data, what you will do, you will just sum xi into pi. That is your expected value. So when you say expected value, it is also kind of a mean.
Hmm.
Okay. So what you will do, you will multiply 5% with 20%, minus 2% with 50%, 10% with 30%. Sum these up, that is your expected value.
Hmm.
So likewise, the rest of process is same. So once you have expected value, what you will do, you will calculate distance from the mean. That is, in this case, it is expected value. Distance of this data point, whatever is your expected value.
Hmm.
Now, like I would calculate x1 minus e of x instead of mu. Now, in case of when you're given probability or this type of data, you say it is e of x. You will calculate x2 minus e of x. You will
Hmm.
calculate x3 minus e of x.
Hmm.
Are we clear so far?
Yeah.
Okay. Then earlier, what you did when you were calculating covariance or variance, when
Hmm.
you were calculating variance, after calculating distance of data point from the mean, you divided it by n minus 1. But again, when you are given a probability distribution data, what you will do, this is first deviation, you will multiply it with this probability. So this into zero point 0.2, this into zero point 0.5, and this into zero point 0.3. So this thing, x minus, so expectation of, now it is little tricky. Let's not go to covariance first. Let me talk about variance of x first. Then I can talk about covariance of xy when you are given this type of data. See, honestly, this won't be asked in the exam, but this is like, I encourage you to like know these things. Maybe some you never know, wherever where you may encounter this kind of stuff. But are you following? Like if I just talk about uh any thoughts with are we good together so far?
Yeah. Yeah.
Okay. So what you will do, you will calculate deviation, multiply it with the probability, and like if I multiply probability with deviation, sum it up, I will get variance of x. That's how I can get a variance of x. But but now if I were to get covariance, any suggestion or any hint what should I be doing? Like look at the formula for covariance when you are given the data like absolute numbers,
Hmm.
and try guessing what should be the formula when I have the data where I'm given the probability instead of absolute numbers.
Hmm.
Think I know you can answer certainly.
I think we calculated the expected value, right, by multiplying the probability. Um.
Uh, See, okay, no worries. Let me answer it. So instead of So this was variance. If I directly multiply deviation with the probability, I'm calculating variance. But if I need covariance of x, what I'll do, be very attentive.
Hmm.
I'll calculate x minus expectation of x multiplied with what I did. Like in the covariance, what we did, we multiplied the deviation of both variables. So in this case also, what I'll do, I'll multiply deviation of x from expected value of x, and so this is one term, and I'll multiply this with y minus expected value of y, and then I'll calculate it, the expectation value. So first I will multiply these two, x minus x expectation of x, y minus expectation of y. Then I will instead of multiplying first deviation with 20%, I will
Hmm.
multiply the deviations first from the both variables x and y. Then I will multiply with 20%. Likewise, I can do it for x2 and
Okay.
y2, finally x3 and y3.
Okay.
Little bit
Oh,
you are able to follow, or like
yeah. Yeah, I'm able to follow a bit. Yeah.
fantastic. Can you try just explaining me once? Like it will give you more
Actually,
confidence. Yeah.
yeah, actually the thing is, probably I'll be able to understand it better maybe when I'm doing the numericals.
See, firstly, I'll suggest that don't do anything on this front. It's fine. I mean, from exam point of view, on this, the questions are not asked, but understand this formula. That's important. Yeah. So to understand, I think, like, yeah, I encourage you to do one, at least one numerical, but don't spend much time if you are short of time. That's my suggestion here.
Okay.
Okay.
Yeah.
Yeah. And yeah, this one is little important. So correlation, this is something which you must know. The earlier formula, like covariance, variance, like what you answered me, like variance is the dispersion. If you know that much, that is important. But formula for variance, covariance, it's like very less likely that those would be tested in the exam. So I'll leave that up to you. If you are like interested, you can explore. But this is something which is most important. See, covariance in itself, it doesn't tell you much. Like if you see, there were two data sets given. If I calculate covariance, it is coming this number. I cannot interpret this number. That's why what we do, we define one more term that is called as correlation, which is most important in portfolio management, risk management. So correlation is standardized measure of linear relationship between two variables. So very simple example. If I say that if your salary is increasing, your spendings are increasing. So I can say that there is a positive correlation between your salary and spending. Okay. And if I say that, what else? I can give negative correlation. Mm, what's a good example of negative correlation in practical life? Okay. For a moment, think of health as some quantitative variable. If my salary is going up, my my eating habits are going bad day by day, and my health is going down. So my salary is going up, but my health is going down. So any two variables which head in opposite direction, then we say that there is a negative correlation. Does it make sense? Will you remember these two examples?
Yeah.
Okay. So that's the correlation. And the formula for correlation is covariance over covariance between x and y. So let me just write correlation between x, y, or it is usually written like this: rho xy is equal to covariance of xy divided by sigma x, sigma y. Again, just remember my two examples. This is also something which your calci can directly give you correlation.
Mm.
Okay, so really don't think much about calculations, but understand the terms. That's important. And over here, like very important point to note, correlation. So see, earlier there were few topics which were part of your level 2. Now those have been brought to your level 1 curriculum. So that's why I'm bringing up one point here. Whenever we talk about normal correlation, it is Pearson correlation that we are talking about. There is a proper term. Uh, so if one doesn't specify, he or she just say correlation. So by default, it is understood that they are talking about Pearson correlation, formula for which is this.
Okay.
Okay, because see, one may ask, like the common question should come to your mind, that if this correlation is a linear relationship,
Mm.
then if I know that my direction my direction is same variables, but they are not really in a linear pattern. They might be heading in some like random path. So how do I quantify that? So for that, we have different types of correlation that we would be studying in the upcoming topics, chapters, and papers.
Okay.
Okay, so Pearson correlation, covariance over standard deviations of both variables. This formula you need to remember and understand that correlation is a linear relationship between two variables. Okay,
Okay.
yeah. So properties of correlation. Correlation measures the strength of linear relationship between two random variables, and it has no units. The value of, so range for correlation is +1 to -1. There
Mm.
could be 1-to-1 correspondence in the same direction or in opposite direction.
Mm.
Causality cannot be assumed if the correlation between variables is high. So just scrap this point, not really that important. Just remember this point, range is +1 -1, and it measures the linear relationship.
Okay. Right.
Yeah, very, very good pictorial representation of what is perfect positive correlation. When you say
Mm.
1-to-1 correspondings, when your x is increasing by 1 unit, your y is also increasing by 1 unit. So you say that you have perfect positive correlation, or r is equal to 1. Likewise, on the other hand, if your x is increasing by 1 unit
Mm.
and y is decreasing by 1 unit, so there
Mm.
was an increase in x variable by 1 unit, but your y variable came down by 1 unit. So you say that there is a perfect negative correlation, which is -1. In
Understand.
fact, this is something which risk manager looks for, that they want to hedge. Like if you have got some risky asset, you need some perfectly negative correlated asset, so that if there are losses in the negative like risky asset, those losses should be offset from the hedging asset.
Okay.
Okay. And likewise, you can talk about correlation of -0.7. When you say -0.7, that means if your x is increasing by 1 unit, your y is decreasing by 0.7 units.
Mm.
Okay. Likewise, this is a random chart. So you say there is no correlation. There is no linear. Oh, okay. That you say that there is no linear relation. There is, of course, a relation. When your x is
Relation.
moving, y is moving. But linearity is not there. That's why you say there is no correlation between these two. And over here, it's zero point 0.7. Over here, it's minus zero point 0.7. Does
Okay.
pictorial representation help understanding it better?
Yeah. Yes.
Okay. We come to end of this chapter, so you can just relax. I know it was little heavier chapter after your break, and suddenly, like, I
No
could
worries.
have, because now from now onwards, like, we are done with easy chapters. Now gradually, like this one was still easier, I would say, Now gradually, like the level will go up. Okay.
Yeah.
I know you are like you're full energetic for after your holiday, so certainly you will do it.
Yeah,
And
yeah.
yeah, let's look at the question. An analyst is concerned with the symmetry and peakness of the distribution written over a period of the time for company. She is examining. So there is one analyst. She is examining this symmetry and peakness. She does some calculation and finds the median return is 4.2%. So now you are given median as 4.2%, mean as 4.8%, and mode is 3.7%. Okay, so this will help you determining if you have got positive skewness or negative skewness.
Mm,
Okay, so I helped you with a relation, like we will write inequality, which one is greater than what, and then we will conclude if this is positive or negative skewness, and we are given some further information. She also finds that measure excess kurtosis too. Now be very careful. This is excess kurtosis you are given to. Now
mm.
whatever I explained previously, that is something you have to just recall and apply. Would you like to give a try?
So basically, excess kurtosis is 2.
Yes. Start
So
with this.
we'll
Yeah, this is a simpler part. Good point. Yeah.
uh, 2 equals to kurtosis minus 3, and so the uh, kurtosis is positive,
Yeah.
right?
You seen Crorepati? कौन बनेगा करोड़पति?
Yeah, I've
Now,
seen.
like you can just easily drop 50-50. Like you can be left with only two options. So which are those options? First tell me that. Yeah, you're on the right track. Excess kurtosis is positive.
The
So
kurtosis is positive, and the
mm,
positive one is the
mhm,
leptokurtic.
perfect.
Yeah.
Perfect. Yeah.
So
So
lepto.
which are the
So we'll
options
have
left
to
with you?
see. Yeah. So we'll have to see what the skewness is. So we'll have to see. So my mean. Sorry.
Mhm.
Uh,
Just relax. Yeah, you can. Firstly, we have to find one correct option out of A and D. So
hmm.
50-50, two dropped. Now we are left with two options. Now tell me, what should I do?
I think
Firstly,
I have to see like the actually
position
I
of
forgot that.
mean. Yeah, position
Yeah,
of mean.
exactly.
Yeah,
Yeah,
median would be always in between. So
between.
this median that we are given 4.2%, it would be always in between. Now let's see where the mean is lying. So where what my mean return are?
Mean is greater than the median, right?
So mean is here. Okay,
Yeah.
4.8%, and your mode is 3.7%.
Mm,
Where did my mean got shifted?
yeah, on to the right. So it
So
moves
which
to
one?
positive 8.
Perfect. Yeah.
Yeah, leptokurtic.
Okay. So that's the right answer, I think.
Mm,
So the right answer, yeah, it's in the dark. So it's correct.
mm,
Okay.
yeah, I did.
Are you able
Yeah,
to follow, apply?
yeah, exactly. That it was easy, actually.
I think this one, I think you shouldn't have given, but let's explore. All of the following statements are true, except
Mm,
if the return distribution of two investment have the same mean and standard deviation.
mm,
So now you are given two return distributions which have same mean and standard deviation.
mm.
The one which has more negatively skewed distribution is considered to be riskier. Any comments, any thoughts?
Mm, if the two distribution of two investment and save mean and deviation, the one which has more negatively distribution will be considered riskier. Distribution with positive excess kurtosis are known as leptokurtic.
See, kurtosis for now, this one, like for, okay, okay, you went to second. Firstly, let's explore this one. Option A. So you are told that mean and standard deviation of, you are given two investment options. Say you are given two options, investment options. You're told that for this one, say mu x and sigma x, which is mean and standard deviation, for mu y and sigma y, these are same. Okay, so from ideally, if I were to easily comment, usually we look at the standard deviations, but you are given that those are same. But
Hmm.
you are given one additional information that one of these has negative skew. So
Hmm.
negative skew, that means that the negative returns have the higher probability. So we are saying that that is riskier. Indeed, it is true, right? Because if the probability, when you say probability, it is area under curve, and when you say negative skew, that the
Hmm.
tail region area is slightly more. So the
Hmm.
probability of negative return coming as an outcome is more. That's why we can say it is riskier. So this option is true. We are we are asked to identify which one is false. So
Wrong.
this option is true. Okay.
Hmm. Hmm.
Distribution with a positive excess kurtosis, or known as, I think, yeah, this you can answer.
Yeah, that's true. That's true.
Okay. Now, if two investments have same mean and standard deviation and skewness, now skewness is also same.
Hmm. Okay.
Then one with a lower kurtosis will be considered as a riskier.
Hmm. Hmm. Actually, the thing is,
Mhm.
lower kurtosis would be the platycortic, right?
Yes.
And platycortic, in that the tail is uh,
Correct, correct. Yeah,
wider.
you're on the right direction. Perfect.
So it's
Because
wider, right?
if you look at this, the first statement in the kurtos leptokurtic, it
Hmm.
will have the thinner tails. So if the statement would have been that leptokurtic is less riskier, then my statement would have been correct. But what I have been given is platykurtic is less riskier.
Yeah.
Lower kurtosis will be considered riskier. So platykurtic is not riskier.
Risk.
It is the one with
Leptokurtic.
a higher peak would be
Yeah.
like the leptokurtic and the thinner tail. You can just, along with the leptokurtic, you can just write highly peaked and the thinner
Okay.
tail. And with the platykurtic, you can just write low peakness and the fatter tails. So fatter tails mean it is high risky. So this one is wrong.
Hmm. Yes,
Okay.
that's right.
Yeah.
Hmm.
The last one, I think,
It's true.
okay, great. So I think we solved it. Let's move to the next question. The bond has default probability of 5%.
Hmm.
What is nearest respectively to skewness kurtosis of the distribution? Okay. Hmm.
Hmm.
I think this one you can skip. Otherwise, let me think if there is an easy way to solve this one. Bond has a probability of 5%, which is nearest respectively to the skewness. What is skewness? Skewness is third moment. So what I do, I calculate the deviation from mean and divide it by the sigma cube. This deviation divided by sigma cube. Okay,
Hmm.
can be calculate. Firstly, default probability is 5%. So this is your expected value. What is the nearest respecting to the skewness and kurtosis of the distribution? Okay, to be honest, I'm not aware. Let's see what's there. So it also says that the central moment, let me read it from here. So it says, okay, this is option with the let x equal to 0 with a probability. Okay. So what it is saying, now let me explain you. When you say x equal to 0, that means your bond is not defaulting. So when you say probability of default, which is 5%, so you are saying that when you default, it is 5%, and when you don't default, it is 95%. So outcome x equal to 0 has 95% probability. Outcome x equal to 1 has 5% probability. When I say 1, it is default.
Mm.
Now, what we have been asked is, so 5%, it is a weight. This is also a weight. Okay, we are calculating the expectation first. So this is an expectation. So how do you calculate expectation of this? One, so like as I said that earlier, if you remember this example, hypothetical example I gave you, like I
Mm.
asked you that 5% times 20%, 2% times 50%, and 10% times 30%. Likewise, in this case, all we have is like 195% and 0. Did I write other way around? Yeah.
Yeah.
So when we say default, that is 1, which is 5%. When we don't default, it is 95%. So if I just do, this is x, this is probability of x. If I calculate this, is 1 into 5% plus 0 into 95%. So x into, like as I said, that expected value would be summation of xi pi. So this is your x, this is your pi, this is your x, this is your pi. So my expected value would be, or mean would be 5%. Okay, so essentially this is my expected value. Let's see what next. How come they have, okay, they have directly calculate third central moment. So let's also calculate the central moment. We calculated mu as mu or expected value. It's a one and same thing. But when you're given probability, better to denote it by expected value of x, which is 5%. Now, my x size were 1 and 0. Probability of x size were, for this one, it was 5%. This was 95%. Now,
Mm.
again, I will calculate x minus e of x,
Mm.
and I'll do this for both. So what
Mm.
I'll get is my first x is 1 minus 5%. Is it making sense, Riti?
Yeah. Yeah.
So x is my 1 minus expected value of x, which is 5%, into probability of that. So because it is third central moment, I would cube it, and plus, now my second xi is 0. 0 minus, again
Mm.
my expected value, sorry, it would be 5%. 0
Mm.
minus 5%. So my e of x will remain 5%, which we calculated, sorry, I have calculated here,
Mm.
which I'm using xi minus expected value of x. My xi is 1 here, my xi is 0 here. And for this xi probability is 5%, which I multiplied. For this xi probability is 95%. And I will cube because I want to calculate the third central moment. So if you do this calculation, you will get this as a skewness. Is it making sense?
Mm. Yeah, somewhat. I'll have to revisit and probably do this numerical on my own.
Yeah, but at least for now, is there any thing which need more clarification? I'm happy to do that.
Yeah, so the thing is, I just wanted to understand that how do we know, like, what formula do we need to put here?
See, I just applied the same formula for kurtosis that I told you here, but because we don't have like mu, because the data is kind of your probability specific data. Like as I said that, see, there are two types of datas. Like one, you may be given the like absolute returns, like as I said that you can sum it up, calculate mu, and another type of data could be like you can be given this probability kind of data. So this default one falls under that category wherein you're not given absolute values of what may happen, but you're given the probabilities of what may happen. So it may
And also,
default.
like you have
Yeah,
like 5% is given, then
yeah.
how did you calculate like the 95%? Like, so you
See,
just taking it will default or not default.
perfect. Yeah, that's correct. Absolutely.
Okay.
Okay. So this is how you will calculate skewness.
Okay.
So what you got such that skewness is this one over 5% times 95% to the power 3 over 2. This is something even I think there is something. Okay, standard deviation. Okay. Hmm. Over 3 by 2. Okay. I just take a homework. Like this is
Hmm.
something I'll explain you why
Hmm.
this one, this one,
Okay.
5% into 95%. So
Yeah.
have we covered binomial distribution in our previous chapter by chance? Do you
Yes.
remember?
Yes, we
So
have.
yeah, so if you remember, I had asked you to make a note that for any distribution that we are studying, you can make a note what is the mean and variance of the binomial distribution. Can you tell me what was the variance of the binomial distribution? Sorry, today I'm like doing a lot of brainstorming, but just I just need to ensure that I deliver it properly. What was what is the variance of the binomial distribution? First of all, what is binomial distribution? Do you remember your FRM exam probability of passing? Yes, no, it's fine if you don't know, it's fine. Okay, no worries. Yeah. So, see, variance of binomial distribution, if your random variable is binomial, firstly, what do you understand by binomial? Like, just let me ask you a very basic question. Anything which has outcome like 0 and 1, it's
Yeah.
binomial, binary, right?
Yeah, like,
So,
yeah.
yeah. So, for any distribution which has this kind of outcome, variance of that distribution is p into 1 minus p. If you
Yeah, yeah,
remember
that's
over there,
yes,
it
yes.
was n also,
I've written
number
actually.
of trials. Okay. So
Yeah,
there, what we are doing, so this is my variance. So when I say variance, it is sigma square.
right.
Okay. So sigma square is my p into 1 minus p. So my probability of default is 5%. So 0.05 into 0.95. Okay. But in central movement, as I said, that my formula is that in denominator, I need sigma q.
Yeah,
Okay. So if I just calculate sigma first out of this, what I'll get 0.05 into 0.95 square root, or I can write 1 over 2. Is that
yeah,
correct?
yeah,
To the power.
correct.
So what I need now is cube. So if I cube on both sides, sigma
Mhm.
q would be 0.05 into 0.95 to the power 3 by 2.
Yeah, right.
Is it making sense? I'm
Yeah.
see, to be honest, it's just brainstorming these kind of questions.
No, no,
May,
yeah, I am getting it. I'm getting.
yeah,
But the thing is,
yeah.
so the central movement,
Please do ask. Yeah, yeah, please.
uh, I'm just looking at where I have mentioned the formula, right?
See, from exam point of view, this is something I would expect you to know. This type of question, but this is something too detailed. May not
Yeah.
be directly asked, but good to know.
Yeah, exactly. So basically I'm not remembering the formula of the third central moment and
See,
fourth
anything
central moment.
simple one. Let me explain you the generic formula. What was a variance formula? What is variance? I think let me start with the basic.
Yeah.
What is variance?
Like the deviation from the mean, so it's
Deviation.
like the x
X
x minus
minus
y
mu
minus mu.
square divided
Yeah.
by n. Let's for understanding, let's say n. Okay, so this
Okay.
is your second moment. So in second moment,
Okay.
the numerator is deviation square.
Mm.
When
Okay.
you talk about third moment, which is skewness,
Mm.
your numerator would be cube of this deviation. So this deviation would remain as it is. It is cube. In denominator, it would be sigma cube. So this
Mm.
is the formula for third moment. That is
Mm-hmm.
skewness. Can you
Yeah.
now tell me formula for fourth moment? Just replace 3 by 4th. You can in fact
So
tell me the kth moment. You can just replace
yeah.
3 with k. That would be your
Yeah.
kth moment.
Eighth moment. Yes.
Okay, so this is your third moment. Deviation cube divided by standard
Mm.
deviation cube. So that's what I did all this uh, messy calculations. I calculated sigma from binomial distribution, and I calculated cube that we use. So first we calculated like this deviation cube that you
Yes,
see here.
deviation. Yeah.
These are deviations 1 minus 0 we did cube, and because we need a probability, or in this way, like you need because you don't have a mu here, you have to multiply it with the probability. And once you have this is a numerator basically. From your third movement part, this is your numerator. So
Right.
once you
Right.
have numerator, you are dividing it with a sigma cube,
Mm.
this one.
Yes.
Now
Yeah.
I'll
Understood.
give you
It's basically like um, we are using this formula as we can see the probabilities like zero and sorry, no, we have like two. No, but the thing is, why did we use the binomial variance formula here?
because
Because there are two variables, right?
not really two variables, but the outcome of the variable is binomial. Like it would default, or bond will default or not default. So there are only the random
Two
variable
outcomes.
can take two values, either one default or no default. The
Hmm.
probability of default is 5%, probability of no default is 95%
That's the reason you use the variance formula here. That
of the binomial
P
variable.
one minus P.
Yes.
Hmm.
Okay. Can I give you some homework
Yeah, please. I'll definitely try this entirely
for
because
kurtosis? Yeah, for
yeah.
kurtosis, you do
Okay.
take it at a homework.
Okay.
Of course,
Because the
don't
thing
spend
is,
much time. It just to give you command on the formula, and I'm being open.
yeah,
This
that's
type
what.
of numerical may or may not be asked, but you will understand skewness and kurtosis thoroughly. And but yeah, the more important point is like from kurtosis and skewness point of view, this thing should be clear. What this relationship and the points that told you, like platykurtic, higher peak, and thinner tails. Or
Mm.
sorry, leptokurtic, higher peakness
Yep.
and thinner
And
tails.
thinner tails,
Platykurtic
fatter
tail
tails
and the
and lesser
lower
peak,
peak, yeah, less
lower.
peaked or lower peakness. So those are important points. Like this is something like if you like challenging yourself, you can do it.
No, no,
Otherwise,
I'll do because
yeah,
the thing is, this way I'll be able to, revisit, revise, what earlier I have learned and what the formulas are there. So it's good to, just engage your mind. I'll definitely try this question again.
yeah. But see why I'm again and again emphasizing that. See, your time allocation should
Yeah.
be to the topics which are like more important. That's where I'm coming
I'll
from.
just not
Absolutely.
take lot of time. I'll just try
Oh,
to
fantastic.
revise the, revise the formulas and the topics that I've already covered, right? Because that is also needed. So yeah, I'll do
Fantastic.
that. No worries.
Fantastic. Sure, sure. Fantastic. Yeah.
Mm.
Let's move ahead. I think we are done with the chapter. So let me stop recording first, then we can talk.